Alright, so in this video I want to talk about the special theory of relativity. So first, let's talk about the postulates. It's that first one is that all laws of physics are the same in all inertial reference frames. So inertial reference frames means that it's the same speed. So each reference frame isn't accelerating or decelerating. So let's say that there's a person standing, just standing, not moving. The person could throw the ball up, and if there's gravity, the ball will come back down. Now, if we compare that to somebody that's moving at some constant speed, if the person throws the ball up, the ball is going to have the same speed as the person, right? So when it comes back down, it's going to be traveling at the same speed, assuming no energy was lost, as the person. So it's going to come back down in the same spot relative to the person as it was before. So right back into the person's hand. Yeah, and that's at a constant speed. So the ball is going to have the same speed as the person when it's thrown up, and it's going to come back down in the same spot relative to the person. So the laws of physics that the person perceives are the same for both reference frames. And that's because they're inertial reference frames. So the speed is not changing. Okay, now let's look at an example where it's not an inertial reference frame. So the person is accelerating, throws the ball up. Now the ball is going to have the speed of the person at this time 1. Okay? Now the person is going to be accelerating, so by the time the ball comes back down, the person will have moved more than the ball did, because the person was accelerating. And the ball only had the speed of the person, before they accelerated. So the person is going to be going faster than the ball by the time the ball comes down. So the ball will not fall at the same spot relative to the person as before. So the laws of physics appear different to the person in this reference frame than in these reference frames, right? Okay, now let's look at the second postulate. And by the way, this is just an example of the first postulate. This is not intended to give you an idea of exactly what the postulates are. This is just going over some examples. Really, what this video is going to be about is just distance dilation. Time dilation and length contraction. So now let's talk about the second postulate really quickly. The speed of light in a vacuum is the same in all inertial reference frames, regardless of the motion of the observer or source. Okay. So let's say that there are two people in a vacuum. Somehow that's possible. The first person isn't moving. The first person is moving, and they're both looking at this source of light. Let's say it's a flashlight. Okay. Now, one might think that the speed of light that the second person perceives is going to be faster than the speed of light that the first person perceives, because the second person is moving towards the speed of light. But that's actually not true. This person over here is not going to experience is not going to see a faster speed of light than this person over here. Okay, so that's what this second postulate says. And this can be kind of hard to wrap your head around, but when you do, it's but if you accept this fact, then the intuition is a bit easier. But it's a bit hard to wrap your head around this second postulate. Well, for me it is. I'm not sure for other people. For me personally. Okay, so now let's talk about, again, this is just an example of this second postulate. So now let's talk about this. Let's talk about the length contraction and time dilation. So for this example, I want to use a scene from Star Wars. So in the scene, Anakin is actually on this pillar right over here. And Obi-Wan is on this this rope, and he's holding on to this rope. And he has his lightsaber, and they both have lightsabers. Yeah. And I'm pretty sure in the scene the pillar is moving. But in this, for our purposes, I'm just going to say that the pillar is not moving. But the rope is moving. So the Obi-Wan is moving. This is Obi-Wan. But Anakin is not moving. Okay. Okay. So now let's look at it from a bird's eye view. So let's say that this is Anakin. Oh. What? Oh, okay. Okay. So let's say that this is Anakin. This is the pillar that he's hanging on to. And this is Obi-Wan. And this is Obi-Wan's lightsaber. Okay. The light from Obi-Wan's lightsaber is... Let's say that there are two times. Time 1 and time 2. In the first time, the light from Obi-Wan's lightsaber, at time 1... so let's say there's some light and it's coming out of Obi-Wan's lightsaber, but it hasn't reached Obi-Wan yet. So that's what's happening then. And then Obi-Wan will move in this direction, and in time 2 he'll be a little bit more in this direction. And let's say that at that point the light has reached Obi-Wan, and Obi-Wan can see the light from his lightsaber at time 1. So he's actually seeing a delayed version of the light. Now from Obi-Wan's perspective, the light is just coming directly at him, right? But from Anakin's perspective, it's actually traveling this distance. So from Obi-Wan's perspective, it's traveling this smaller distance because he's moving with the lightsaber. But from Anakin's perspective, he sees that it actually is traveling from time 1 to time 2 because he's not moving with the lightsaber. Okay? He's actually just standing still, so he can see all of this movement happening. But Obi-Wan isn't taking into account the fact that he's moving. So from his perspective, he only sees that the lightsaber is moving this much. He's not seeing that the lightsaber's light actually has to move the distance that he's moving. So, just again, from Anakin's perspective, the light from the lightsaber has to move in the direction that Obi-Wan's going, as well as towards Obi-Wan. But from Obi-Wan's perspective, because he's moving, he doesn't notice that the fact that he's moving, because he's in that reference frame. So, well, he does notice the fact that he's moving, but relative to the lightsaber, he's not moving. So he sees that the light from the lightsaber is coming directly towards him. He's not taking into account the fact that he's moving as well. So the two distances that Obi-Wan perceives and the distance that Anakin perceives are different. Now, if the same amount of time passes for both of them, then that would mean that the speed of light for them is different. But we know that that can't be true, right? So we actually have to say that the time that passes for Anakin, because he's perceiving that light is traveling a greater distance, it actually has to be more than the time that passes for Obi-Wan. Okay? Because he sees that that the light from the lightsaber traveled more distance than Obi-Wan sees. So that means that more time for Anakin has to pass than how much time passed for Obi-Wan in order for the speed of light to remain constant for both inertial reference frames. And I guess I didn't mention this, but we're assuming that Obi-Wan's speed is constant. Okay, so that is time dilation. because the amount of time that passed for Anakin is more than the amount of time that passed for Obi-Wan, time's actually passing slower for Obi-Wan because he's moving. And that is time dilation. So time is changing to compensate and make the speed of light constant in both reference frames. Okay. Now let's talk about length contraction. Okay. Let's make a new example. Let's say that Anakin's here again, but let's say that Obi-Wan now is holding his lightsaber like this. This is Obi-Wan here. Okay, he's moving in this direction. Okay, so let's say that he's directly in front of Anakin, so Anakin can see him directly in front of him. Now, actually, I have to redraw this lightsaber. Just so that it's... There we go. Okay. I'm just not going to draw Obi-Wan because he's not relevant to this right now, but he's there. Now Anakin, right here, he's on the pillar, it's not moving, but the lightsaber is moving. Now this handle, right here, is moving towards Anakin, and this point on the lightsaber, farthest from the handle, is moving away from Anakin, right? The distance between this point right here and Anakin is shorter than the distance between this point and this point, right? So this point is moving away from the point that it could be to be closer to Anakin, and this point is moving closer to the point that it could be to be closer to Anakin. Yeah. But I won't get into that right now. Just know that this point right here is getting closer to Anakin, this point right here is getting farther from Anakin. It's moving away from him. Okay. Now if we think about the speed of light that is coming from the tip of the lightsaber versus the handle of the lightsaber, the tip of the lightsaber, let's call it S2. Let's say that that's the speed, and then let's say that the speed from the handle is S1. S for speed. Now, one might think that S1 is actually going to be more than S2 because this handle is moving towards Anakin. So that increases the speed of S1, and this point over here is moving away from Anakin. So that decreases the speed of S2. But this is actually not true. Okay? And we'll talk about why right now. Okay. But we'll talk about what exactly happens. Okay. So what's going to happen with Anakin is Anakin's going to perceive a more delayed version of the lightsaber here. Okay? So at this point, he's going to see more delayed than he would if it was just traveling at a regular speed of light, right? Without moving away from him. If it was just not moving away from him, he's seeing a more delayed version than he would if it wasn't moving away from him. So the regular speed of light. Now over here, at the handle, he's seeing a less delayed version than if that handle wasn't moving towards him. It was just standing still. He's seeing a less delayed. So we'll say more delayed, more delay, less delay. Okay. Now that's a problem, right? Because we just said that these two speeds can't be different. And the fact that there's delay, that there's a difference in delay between these two, basically says that these two speeds are different. So what happens is, well, first of all, before I talk about that, let's just talk about what sort of lightsaber he's going to see. Well, I just said that over here he's going to see a more delayed lightsaber, right? Because it's moving away from him. So instead of this point over here, he's actually going to see a point that's a little bit farther back, right? And that's gonna be true for all these points. It's not just true for this point. It's for all the points that are moving away from him, right? So it's all gonna be a little bit squished, right? Squished this way. Now on this half, he's seeing less delay, right? So what he's actually going to see is it's going to be a little bit closer to where it would be normally, right? He's seeing less delay, so it's going to be shifted this way, right? Whoa. It's going to be squished this way. Okay. This point moves up because he's seeing less delay. This lightsaber is what he would. But oh shoot! I forgot to mention this. This lightsaber that I drew over here is what he would perceive if it wasn't moving at all. Okay, if it wasn't moving at all, it was all just approaching him at one speed. That's what he would perceive. This is what he perceives when it's moving, because he's seeing more delay over here, he's seeing less delay over here. Okay, right? So let's say this is closer to where the actual position would be. This is just what he would see if it was all just the regular speed of light. What happens is, because it's moving, this is going to be more. This point over here is going to have more delay. This is going to have less delay. So what he actually sees when it's moving, so this is what he sees when it's not moving at all, okay? There's no speed of light difference between these. This is going to approach its real destination because he's seeing a less delayed version. So this point right over here, is going to be approaching its a more accurate destination than before, right? It's going to be what he sees is going to be closer to where it actually is, right? So it's going to be further this way at the time that he sees it. And this point over here is going to be farther from where it actually is. So it's going to move in this direction, farther from where it actually is when he sees it. Yeah, so that's why he sees this sort of shorter version. Now we know that can't be true because the two speeds have to, or assuming we're accepting the special theory of relativity, we know that this can't be true because the two speeds cannot be different. So there can't actually be more delay over here and less delay over here. So what happens is the actual distance of the lightsaber would change. This lightsaber's distance actually does, the length of the lightsaber actually does contract. So this is the new length of the lightsaber. Okay, so it's going to contract so that what he sees is actually accurate. And if what he sees is actually accurate, then that would mean that the speed of light for all the points are the same. This is going to be shorter than what it was before. That's what he's going to see, right? And then, but we know that this can't actually be what he sees if this is what the lightsaber actually is. So what the lightsaber actually is changes to be shorter, so that the speed of light is the same from all of these different points. So this is what he actually sees when it's not moving. This is the new lightsaber length while the lightsaber is moving, okay? And the reason that happens is because otherwise that would mean that the speeds from the different points on the lightsaber would be different than each other. And you might be thinking, oh, well, that only applies when one part is going closer to him and one part is going farther away from him. But it actually doesn't matter if one point is going closer to him and one point is going farther away from him, because when any object is going away from him, or when any object is moving, right? So let's say that This is the new location of the lightsaber. Let's say Anakin is over here. This part of the lightsaber is still going to be moving away from Anakin faster than this point is. So this point is moving away faster than this point is moving away from it. So it still shrinks because the speeds of these two things are still going to be different, right? Well, they're not going to. So this is S2, or sorry, this is S1. This is S2. Okay. One might think that the second speed, S2, is still going to be slower than S1. One still could think that, right? Because this is going away faster than this point is. But because it shrinks like this, they become the same speed. So again, it doesn't just apply when one thing is moving closer to him, one thing is moving away from him. It just matters that that one point is moving farther from him or closer to him at a different speed than one thing is moving farther or closer to him. Okay, and this applies to anything. So even something that's really small, like an atom, if it's moving, then one point on the atom will still be moving away from you farther than another point on the atom. So it will still shrink. Even if one point isn't moving closer to you and one point isn't moving even if both points are moving farther from you or both points are moving towards you. Yeah, so that's distance, that's length contraction. Yeah. So this is just one way of thinking about time dilation and length contraction. I'm sure there are other ways to think about it, but this is just a loose intuition for it. Yeah. Thank you.